Hi, this is Chris Poor with Assured Information Security, and in this video I'll be going over the Attack tab. Before I get started, let's choose my hardware. I got a B210 connected. Okay, so the idea behind the attacks is that you're doing something to a target. You're running some code and you're changing variables to set up that code while it's running, before it's running, and you kind of want to see how your target reacts. It's pretty straightforward what's going on right now. There's not much intelligence built into it where, like, if you throw a bunch of things at the target and you kind of see how it reacts, how vulnerable it is there's no vulnerable analysis built in yet, but I want you to imagine that it could be if you run these attacks in a certain way. So I have two videos going right now. There's me doing everything here in Fissure, and then I have a desk set up with a lamp connected into an X10 outlet switch. That's in the middle there. And I have a router set up as well. So lamp, X10 switch, router with lights. And I'll be doing things to those targets. And well, inside this lamp is a Z-Wave light bulb too. So there's extra stuff. Let's get started with that Z-Wave light bulb. Why not? So when you're doing attacks, you can choose by protocol, by modulation type, by hardware, and each one of these is a file. So if you want to do something like change the color of the light bulb, you can select a repetition interval. I'll make it go slower so it doesn't cause damage to anyone. So if you don't like flashing lights, don't look at this next couple of seconds. Here we go. Hopefully the color comes through in the webcam. Everything looks kind of the same color on that webcam. But every second, it generates a new message, changes the color of the light bulb. I can change the variables while it's running if I wanted to. Depending on the flow graph, if it accepts those changes or not, if there are callbacks to those variables. This is an example of a flow graph. I'll stop it. There are notes here telling you it's in the title block of the flow graph. You can write notes, and this is where I get it from. So you can enter in your own messages. Here, I'll just show you. You can view the file. So this is the file I'm running right now. Where do I keep the notes? Or no, I create a special notes variable. That's how I do it. And I read that variable. This is just a flow graph. If you haven't seen one, there you go. Yeah. So you can change the values beforehand. So if I want to transmit this, this will turn it red. Stop. If I wanted to turn it white, I can change these RGB values to all Fs. If you look carefully, it says like 02, 03, 04. Those ones are the RGBs. Hit start. There we go. And the light again. That's Z-Wave. I could also receive things. If I could choose a different protocol, like if I want X10, I can turn it on and off. A good way to test that is with this multi-stage tab up here. So if I want to turn that switch off, the X10 switch, I can turn it off and on, generate So 5 seconds off, 5 seconds on. Let's speed it up a little bit. You can change the values of each flow graph before it runs, and what's going to happen is it'll run the first one, and then it'll run the second one. That's multi-stage. They could be the same type of thing, like I'm turning it on and off, or they could be two completely different protocols and stuff like that. Like I could open a garage door opener, turn the lights off, hack the Wi-Fi, just make a big chain of attacks. And hopefully you saw the light turn on and off in the video. That is multi-stage. There's not much else to it. It just plays them one after the other. Fuzzing, there are different types of fuzzing you can do with Fissure. So if I want to fuzz an X10 message, there are only 4 fields, but the way the fuzzer works is you can choose a packet type or a subcategory. You'll see default values, things that are in your library already. You can choose certain fields to fuzz. If I want to fuzz a data code, you do random or sequential fuzzing. So if I go from 0 to 255, it'll just fuzz this field and it'll automatically do the CRC values. So it'll adjust the inverse here without me having to do anything. And I can do it every second. So this is helpful if you don't know what your target is vulnerable to, like which messages affect your target. You can just go through them all and see which ones will turn the lamp off. Might take a second. Maybe I should do random. But eventually it'll find one that turns the X10 switch off, turns it back on. I don't want to wait for this. Let's switch it to random. It might happen faster if I do it this way. Yeah, see something happen there. And something turned it back on and off. So I have no real control over this, but I can go back and see like which messages did it. Let's stop it when it starts back up. Here, stop. So I go back and say, like 4 or 5 of these turned it off. Let's look at those closer. You could also do flow graph fuzzing. So if you select this variables option down here, you can load in a flow graph. So if I do an X10, I guess on or off message, whatever, doesn't matter. You can select certain variables that will let you fuzz them. So like if you want to fuzz the transmit frequency, you can do min and max values and put a seed in. So this is helpful if you want to do like physical layer fuzzing and not so much mess with the data. So if you want to do it different power levels, sweep through all these frequencies randomly, like kind of simulate frequency hopping, you can do that. It's going to be real slow, but you can do it. Well, that's the 2 types of fuzzing. I've used it before for ADSB mode S. So you can do real complicated messages with the things in your library, and these are pretty complicated messages. The trick to ADSB is that it needs to receive an even and odd message. So if you sequentially, I think it's the frame format, if you go back and if you just like fuzz that and then you fuzz the latitude and longitude randomly, it'll kind of simulate an even and an odd message. Look at the defaults. Yeah, So that value right there. And that's how you get the plot on a map. You'll see videos of me doing that. Like I posted on Twitter and stuff. I'll make better videos of like me doing attacks against real devices. I've also used it for RDS fuzzing. This needs to be fixed just because I'm reusing a flow graph, like the GRRDS transmit flow graph, and the sample rates are kind of messed up. So when I click start, I have to wait like 10 minutes before it takes effect just because of all the resampling that's going on in the flow graph. So I got to modify that. But once it starts going, it goes, 1 second. But I have to wait forever for it to clear out those buffers. Okay, so that's the fuzzing. Those are the basic attacks. What else do I got? So you can use SDRs, but you could also target Wi-Fi. So you could do it in monitor mode, or you could do it while connected to a network. It doesn't have to be. It doesn't have to be a wireless attack. It could be a wired attack on a network. It's the same principle. You're just loading in a script and running it. So I think these are mostly Python scripts. And I can load in Python 2 or Python 3 scripts. I got that router set up on that table. And if I want to reboot it, it'll automatically guess whatever interface name I have set up here, or I can just click the button and it'll guess it. Right now I'm connected to the router. So this attack requires me, while joining to the network, executes a reboot command on the device using a single UDP message. So this is like a public exploit for a router. Let's look at it. Excuse me. So in order to get these default variable values, Fissure needs to put like a header on the front of a file. If you just copy and paste this and you replace it with whatever default values you want to show up in the table, it'll work. So I want the interface, I want the IP, and I want some notes. And that's what I see in the table. And the rest is just doing the exploit. So this can be found online. We're not going to show that here. So I change the IP, I hit start. Run my script. It could be any script in the world. It's a Python 3 script. It runs it, does the exploit. Takes about 20 seconds for it to take effect. And if you watch in the other video, hopefully the lights on the router will turn off and turn back on as it reboots as soon as this window disappears. There it goes. And it's doing it. Yeah. This Wi-Fi light went off. So the exploit was successful. You could do ones where you're not connected to the network, have the same effect. You could have a light show up on the router. Whatever you want. So yeah, you can create lists of just known exploits for routers if you'd like, or you can do other protocols. You can do wired attacks, wireless, doesn't matter. Just use your imagination for what kind of protocol, and it's a nice way to keep everything together. So where else can you have all of these Python scripts and flow graphs just ready for you to just click and change the values and transmit? It's nice. It's a pretty powerful tool. If I start it, there's a lot there already, but there's a lot more that I can add. So it's gonna grow and it's gonna be nice. There's a history here that just shows you like everything you've done. This is all I've done in this session. You can save that to a file as part of the log. And that is all the things in the attacks, I believe. I have lots of videos that I'm releasing on Twitter of me attacking different targets for these different protocols. I got most of them out already. But yeah, send me scripts that you have for things or ideas to improve this. It may or may not change how I call these files for flow graphs. Like I may use parameter blocks as opposed to what I'm doing now. I'm actually I'm importing these files in Python, and I'm tweaking the defaults that way so I can start and stop the flow graphs. It's useful for me to tweak the values while it's running. If I use the parameter blocks, I can't really run the flow graph in the same mechanism I'm doing now.